So you might want to also look to see how some of these um, bits correlate to each other. Correlation plots is another lovely feature. Of course, in the long window. There we go. I'm going to bring that up here. And so now you could say, take two of our favorite elements, iron and chromium potentially. There we go. And now you get a correlation plot that shows the relationship of iron and chromium, iron in the X, chromium in the Y. You can now, of course, if I zoom in again, it'll also zoom in now tricolor map and the correlation plots all snap together. Very handy. I can unzoom here. And we should hopefully see, you'll often will see some weird things when you look at your unzoomed data because you have that strange pixel on the left side here creating artificially high things. If all your data is really low, you'll see all your data clustered over here and all your really weird data on the far right. And so again, if we do that edge removal, it'll automatically look much better. We may want to know where is this particular region, for instance. We can make a mask where we say define a mask. And now I can click on the graph here and lasso an area. When you're done, all you need to do is double click anywhere and it will close the loop. You don't need to be right on this particular spot. So don't worry about it too much, just double click and it should close. It's gotten better than it has been in the past. Often if we had really, really, really large data files, you can never close that loop. If you go to, I want to say, analysis and say close mask, that's the same thing as double clicking. And so if you did have a problem with not being able to close with a double click, go to analysis and close mask, and that will close it. Also, if you were on a larger keyboard, like in my office, my desktop actually has a real keyboard rather than my laptop one. At least on Windows, I have no idea for a Mac. If you hit the end key, it will also close the mask. So things that I always forget about that I've never done before. So that gives you your mask. You can see that there. I can come back to here on my data set and say, use mask. And those are those areas now that we just lassoed on the correlation plot. Showing that there. And if I go to the chromium channel, those are those really nice high chromium spots. And I can see how that is in the context of everything else there, right? It's on the main SMAK image here. The green button's in the very bottom there. Use it. So that is one way to make a mask. Correlation plots are always very handy to make those kind of loops on your data. I may also just want to make a manual mask. It's like, maybe I say, I really want to know this particular nodule here. So I can even zoom in here with control. I've got a nice, good look at that. And to make a manual mask, I'm going to hold the shift key. I'm going to be very important here to say, you're going to hold it down and you're never going to let it go until you're done. If you do let it go, you'll probably get it confused and you'll probably need to restart SMAK again. So hold it down. I'm going to start here and you see I make a little white line. I'm masking out my area. I'm voraciously holding down the shift key, not letting up. And I'm going to meticulously draw a lovely line around this chromite grain here. And again, double click here and it finishes the mask and closes it. And down on my other screen, it pops up the, what do you want to do with this? Now you can say, what is the spectra from that area if you've loaded your spectra file, which we haven't done yet, but we'll come back to that. But I can say, just make a mask of that. And there's my mask. That's applied that mask and I'm all good. I can clear the zoom and edge remove again. I just see my little mask here. But now I'm really curious to know where that particle that I drew a little mask around lies in this space. So if I go to color, I can go to the color theme and I can say highlight mask. And those are those points that I just lassoed. And so you can go from mask to image or image to highlight that mask on the other side. And it's a really handy way to do that. And now, of course, if I go back and do my manual mask here on the correlation plot again, so I can clear the mask and define again and draw this box here. And now, even though I've drawn it, it'll highlight that too. So even if I'm doing manual drawings here on the correlation plot, I can now do something like draw. Say this mask is those areas there. Good so far? There's lots of things we can do with these masks. We'll go more into those in a little bit. Let's see, do I have?
How did you do this last time?
Oh, I've left this on the highlight mask, and I drew a mask here. And even if I draw a mask on the correlation plot, it'll keep it highlighted in this color scheme. I often work in a dark room, and so I like dark backgrounds. If you're trying to save your ink somehow, you can always say swap colors, and it'll give it a grayer, whiter background and darker colors. It all depends on what you prefer. And smaller dots if you do the swap one. Go back to swap colors. Now, also notice that when you get a lot of points, like in our low background area here, it's all just one big mass of green. That isn't always helpful to see trends in that area, if there are any. So we can also go to color and go to density plots. And now this color codes the pixels there as a function of how many pixels are in that area. It's all relative to the maximum, but you can kind of see there's a whole bunch of pixels that are down here, a little bit that are here, and a few that are up here. And now you can use this now to say, okay, well, that's really cool. Where is all my real data existing? You can say all my real data is in this little area right here. So let's take a look at that better. I'm going to assume that this one at the bottom here is probably background. And you could say use mask. Oh, look at that. It's this guy right here. So there's a whole bunch of pixels here in this, what I believe is an olivine grain. Zebra. Iron. Use mask. Ignore mask. Okay, clear that. Pop that again. And that same way, we can also, I can come back here. I'm going to go back to the highlight mask. Oops. And then turn off density plots. There we go. And I'm going to define that mask on the top here again. Right? And that shows, again, this area here. And now you could say, well, how does that relate to my other favorite element, manganese? And so now you can see how that correlation you picked in one correlation maps onto another element's correlation. And so it's a nice way to carry this through. Now, these plots are nice, and for presentations, I might just screen capture things and let it out. But if I'm going to actually make a figure for a real paper, I'm not a big fan of the matplotlib necessarily. So you may want to put this into your favorite plotting program. If you go to File, and most everything you have, there's an Export button. If I click on that, it will say in the left corner here that the correlation data was saved to the clipboard. And where's my mouse? I can say, not that I would ever plot anything in Excel for a publication, for God's sake, but I can at least put it in here. And if I now paste, hopefully, we can also see that it gives you two sets of coordinates in this case. One's the green points and one of the blue points. And so anytime you have a multiple set of things on the correlation plot, it'll give you a pair of X, Y for each one. That'll become even cooler a little bit later on. We'll come to other things here. There's some other cool things we're going to do with multiple files and pixel colors and clusters, but we'll come back to that as we go along. And you can also say only show the mask. So you can also eliminate all the other green points and only show your blue points. If you kind of want to just see one trend. This can also be handy. You may, so if I come here and I'm going to undo that for a second here. This is actually really good because I even forgot I even had this function as of yesterday. So it's a good thing we're going through this, right? So you may want to know what the correlation is between the manganese and the iron here, let's say. And I particularly want to know it in those in those two chromite grains. And so if I try to fit this entire data set, I got data up here and over there. And so I can say, do an analysis and do a regression. And in this case, it actually is fitting my nice set of highlighted data here, right? I think if I undid my highlight mask, oops, no, do no color mask there, and did this again. Yeah, it's going to find the lower one there, right? So if I use that highlight mask, or if I used the well, you got it. Color theme, only show data mask. You could fit that independently. Oh, see? Still fits the entire data set even with that. So you definitely want to use the highlight mask. There we go. And then now you know the slope correlations between the counts of both of these intercept, how good the data matches. If you were going back to this full data set, let's go back to none. There are also times when you're looking at multiple correlations in the data set. You may want to fit both of those, not have it overly biased. Maybe you don't want to draw. You can also try to do a multi-regression. And so we're going to try to do, let's see if we do two slopes. You got to kind of give it a guess. I'll make that one larger. It tries to give you some good starting values. And here it fit those two. Again, you might want to, it's hard for it to actually regress this particular line here because there's only 5 or 6 points in it. But it's going to try to balance as many regressions as you could. You might add like 4 or 5 regressions and try to figure all the little different slopes you might have in the data set. Some of you will find data sets where you have like fingers of data that come out like that. And then you can try to fit all those together in one big batch rather than try to highlight them. It's probably better to highlight them, but this was before that was on there. So that gives you both slopes in this case. We could even, we'll take this one here. We'll take this bottom one here. So that's the lower slope, right? 0.01, 0.02. We can say, let's set a mask based on slope. And so I'm going to use that 0.019 and the tolerance on that. So plus or minus, so let's say maybe 0.01, because otherwise that's way too big. And there's the mask it made of a 0.02, oops, 0.02 line, plus or minus 0.01. And then we could go back here now. So it actually made that whole area, closed it up. If I go to my highlight mask, it should be there. And we could say use mask here. And those are all the bits that fall into that category. Again, that's good if you're looking for a particular relationship that has a concentration ratio or count ratio that you're particularly interested in. And the narrower you make it, the finer you get, of course. So we're skipping ahead a little bit, but this is how I like to do this. So as questions come up, we'll move around. So it's nice to have these masks, and quite often, particularly if you're drawing them or you're particular with them, it's hard to reproduce because if you close SMAK, you may lose what you've been doing. I don't have a full session manager in SMAK at the moment. I'm being convinced otherwise slowly. But say you want to come back to this for posterity later on. There's an option here now in our main SMAK window where I can go to Process, and I can create a new channel from a mask, right? And so I often will use this if I'm trying to compare masked areas and do other things with them. As you can see, we'll see later on as we go along, you can do lots of things with masks and comparing different masks. So I'm going to create a new channel from the mask, and I'll just call this Regions of Interest, because that's a nice boring name for a new channel. So now that's ROI. So here it is. If I go to ROI, we can see that we created a giant mask that has all that area right there, right? That's all that bottom area. Now, let's make a new one. I'm going to clear the mask. We'll set another slope mask up, and we'll make this one like 0.5 and 0.02 maybe. That one's kind of weird looking. Let's do a different one. Maybe you want to do let's see. My manual math is not great right now. Let's say 2.5, 0.1. There we go. We'll do that one. And then we can highlight that mask. If I go back to my main map here, and I say use mask, you'll see that it covers those spots right here, right? I can go back to my ROI area here, and now I'm going to say process, add mask to channel. I'm not going to create a new one, but I'm going to add the mask. Okay. If I ignore this, you'll see that I have that first mask is a bunch of ones, where I have no mask is a 0, and where I've masked this out are now 2s, I hope. Yeah, 2s, it's hard to see. 0, and it goes by powers of 2 as I mask these along. So I could have overlapping masks. If I had a 2 and a 1 that overlaid, it'd be a 3, right? And now I could even take this and go back to my favorite particles over here. Chrome, right? I can do a manual mask just for fun and call that this, right? Come back here to our ROI area, and now process will add this mask to the channel. There we go. Now we have areas up here, blues, yellows. And now I want to see how this all lies on our correlation plot graph again, right? So we can clear this. I'm on the ROI channel here in our main data set. And for color, we are going to go to cluster. And there you go. And so this works as we'll do this with clusters later on too, but it does for any kind of color scheme here. You notice that we even picked off the exact color map for our colors here, so it's a nice, perfect correlation. If you changed your color map from jet to something else, it would also make those points the appropriate color map changes. So you can see the highlights of the different masks here, the big blue area there, and so on and so forth. After you've done a bunch of things and you want to save that data, I recommend that you go to Save Processed. This will save the data. When you do that, we automatically append an underscore process to it. And you can change it to be more detailed, like I made an ROI or something. The whole idea here, though, again, is that you never delete your original data set if you can all help it. So never overwrite your original data. Always keep at least one pure copy of your data set. Otherwise, you'll curse yourself later because you've ruined it all.